these just because of all the 2-hour delays and snow days and remote days. So this is 5-3 GCF with Magic X. So way back when we started here, we were just taking out the GCF of each of these terms and finding whatever factor went into both. As you looked at the bottom, a lot of these GCFs now had variables as well. It's also important to notice in something like 12 that you can take out a variable greater than just x. We took out x squared. Okay, so that was 5-3. My papers are leaving my binder. Okay. So I don't believe that was that your Magic X, or did you have a slightly different one? This might be yours. I have a couple Magic X worksheets at this point. I believe this is yours though, correct? Yeah. Okay. Okay, that's just the lyrics to the video I had you watch. And then we move over and we get to 5-2 or 5-3 grouping. Alright, so for the grouping handout, hopefully we did A-okay with that. I know that it was a little bit more complicated because you are looking, in that case, at multiple variables mixed together. So there's the top half, here's the bottom. Okay. And then we looked at perfect squares and difference of squares. So again, difference of squares says that if you have two terms and they're both perfect squares, then they're going to factor as the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Perfect square trinomials will have a perfect square at the beginning, perfect square at the end, and the middle term will be 2 times the square root of each, and they factor as the same thing twice. So anytime you have a perfect square trinomial, you can actually write it as that binomial factor squared also. So you could have written those as a squared factor as well. And then we got into factoring with a equals 1. I believe your handout was this one. Yeah. Sorry, I know first 7's kind of hard to see. It's x minus 9x plus 1, and that's x minus 7, x plus 3. I'll try not to do them in pencil. Okay, and then on the back, you have x plus 9, x minus 2. That's x minus 6, x minus 1. X plus 11, x minus 2, x minus 12, x plus 2, x minus 14, x minus 2, x plus 10, x minus 3, x plus 9, x plus 4, x plus 11, x plus 1, x minus 16, and x plus 2. And then the last one, 5-3 day 1. When I was checking this yesterday, a lot of you guys did really well. I definitely saw a lot with primes and like the right spots. So when I was looking over this, I thought we overall did a pretty good job. So again, 5x minus 7, x minus 2. This one's 2x plus 5, x plus 2. 3, y plus 1, 2y minus 5. And then we have 4x plus 5, 3x minus 1, x plus 6, x minus 1, 6x minus 24, x plus 1, and x minus 5, 5x minus 30. Now, in this problem here, if you kept your GCF out all the way through, you had 5, x minus 5, x minus 6. This is probably the answer I would have gotten, but down here I have 2 alternative answers in case you missed that GCF. So in number 7, that's a case where you could have factored this 3 different ways, and all 3 ways are correct. These would just have the option to pull out a GCF. Okay, that happens in number 9 as well. Here's the example where the GCF is pulled out. Here's where if you accidentally leave it in. And then number 10, that was a case of a perfect square trinomial. So you got 4x plus 5, 4x plus 5. So even though this is one where you could use our magic X and do factor by grouping, at the end you could see from your answer exactly what type of factor it is. Okay? So hopefully that helps you go through just sort of like a technique called factoring by taking the square root. So we are going to move into the last part of 5.3. And then I believe we have one more section before our mid-chapter quiz. I may give just a quick quiz on factoring, not a full period quiz, just kind of something where I can see that we know each of our techniques, and just to make sure we are working through each of those and are confident. Okay, so the new part of our lesson today is that we are taking into account a technique for solving factors, and that technique is going to involve a square root. So just at the top of that page, I have some vocab reminders, and on your handout, I already gave you the formal definition. So up on my screen, I have the examples. So a squared number is when you have the same number multiplied by itself. So a squared number would be like 4 times 4. You can write it as 4 squared equals 16. A square root is the value of a number that you get when you have a square root over it. So like the square root of 30, for example, is approximately 5.5. A perfect square and a perfect square's root become a whole number. So like the perfect square root of 81 becomes 9. So by definition, perfect squares are numbers whose square roots are integers. So perfect squares are numbers whose square roots are integers. So here this isn't an integer because it has a decimal. And then a radical is simply the symbol we use for a square root. So a radical is the name of that symbol. So go ahead and take a minute and fill in your perfect square chart. So go ahead, take a minute and fill in your perfect square chart. Alright, so the reason I have you filling in this chart is because those perfect squares are going to be so important. They're the numbers we're looking for when we're solving by square roots. We're dividing by these numbers, and we're utilizing these numbers to help us solve without having to factor. They're also going to come back into play when we use the quadratic formula as well. Alright, so we're solving by taking the square root of both sides. This only works if we have x squared equal to k. So this only works if you have x squared equal to k, and then k has to fit into 2 of these categories. If k fits into the first category where it's negative, then there are no real solutions. So if k is negative, then we have no real solutions. So basically what we're doing is if there's stuff multiplied to x squared or on the same side, we're solving for x squared. So this instance or case only works, and this is the key feature, this only works when the b value is 0. So we talked a lot about standard form and understanding what a, b, and c is. This case is special. It only works if b is equal to 0. So this case only works if b is equal to 0. Okay, so here's an example with 3 different equations. Equation A, you have x squared equals -5. My k value is less than 0. Therefore, the number of solutions is 0, meaning there are no real solutions on my graph. So this would be a case where the graph does not cross the x-axis, and we should know that x squared plus 5 would represent a graph shifted up 5 units. Its vertex would be 0, 5. So we could see, hopefully, from a graph shifted up 5 units with a vertex of 0, 5, that it would, in fact, not cross the x-axis and therefore have no real solutions. Letter B, you have x squared equals 0. In this case, since x squared equals 0, we get one solution because my vertex is on the x-axis, and that solution is at x equals 0. And in example C, I have x squared equals 7. 7 is greater than 0. This gives me 2 solutions at plus or minus the square root of 7. So when you have 2 solutions and there's a square root, you can write it as a plus or minus in front or as 2 separate radicals. You can write it as a single or 2 separate. Okay, so we have x squared equals 81. So the old way is over here in pink. The new way is over here in blue. So you can compare old to new. So this would be if you got x squared equals 81 and you're like, oh, that's a difference of squares. Then you subtract your 81, set it equal to 0, factor as a difference of squares, and solve for x. So doing it the pink way isn't wrong. That's how you would have done it yesterday. Today, though, we're learning this new technique that says if we have x squared equal to 81, then I can take the square root of both sides, giving me x equals plus or minus 9. Making my 2 roots at 9 and -9. So again, these are the roots of the equation. In example number 2, you would again compare old to new. So our new way says divide both sides by 2. You get x squared equals 16. Take the square root of both sides, and I get x equals plus or minus 4. So you can see how much solving by taking the square root significantly reduces the amount of steps you can take. Now again, this only works if b is equal to 0. So this is a special case and does not work for all equations. So it's a special case and does not work for all equations. Okay, so number 3, we're going to move over that 486x. Then you're going to divide by 6. And then you are going to square. In number 5, you have 3x squared minus 9 equals 0. So we divide both sides by 3. And then you square root both sides. So this is a case where we don't have a perfect square. Therefore, my answer is plus or minus root 3. This would also be an instant in which this problem would not be factorable. So you could not factor this problem. This is a non-factorable problem. So if you were to be told to factor this, you would get prime. Okay, in number 6, we're going to divide both sides by 4, square root both sides, and once again, you have x plus 4 equals plus or minus 1. We do our double split and solve for our roots. So the last unique part of lesson 5.3, in all of these problems recently, we've been getting roots as our answers. The last thing we're going to look at is what could I do with those roots in terms of an original equation. So now what we're going to do is take roots and go back to the beginning. So I keep saying that like a lot of what we're doing is FOIL and reverse. So now we're actually going to FOIL again. So foiling and reverse foiling and factoring and solving are all intermixed. It's a big circle and we keep playing around. And we want to look at each part. So I'm going to write the next part out with you kind of by hand so that you can follow along. Okay. So we're down at the bottom of that page. So we're looking at writing a quadratic equation in standard form given two roots. So what we're going to do is say x equals, and you could change negative 2/4 to a half. You could leave it as negative 2/4. Doesn't matter. So x equals negative 1/2. X equals 2. And then what you're going to do is get both of those set equal to 0. So I'm going to do that by multiplying both sides on this equation by 2. So I have 2x equals negative 1. And then I'm going to add 1 to both sides. So I get 2x plus 1 equals 0. And then over here, I'm going to subtract the 2 to the other side. So I get x minus 2 equals 0. And then I'm going to take 2x plus 1, x minus 2. And because it asks me for standard form, I'm going to FOIL. And combine like terms. And the standard form of a quadratic with these given roots is 2x squared minus 3x minus 2. So this quadratic equation has these given roots. Let's try again. So we have 8x plus 3, 8x minus 5. So we FOIL that. And you get 64 minus 16x minus 15. Okay, number 3. You have x equals negative 1 and x equals 3. So you get x plus 1, x minus 3. So you get x squared plus x minus 3x minus 3. Or x squared minus 2x minus 3. Number 4, x equals negative 2, x equals 6. So that becomes x plus 2, x minus 6. X squared plus 2x minus 6x minus 12. X squared minus 4x minus 12. So again, everything's sort of coming back full circle. We used to start here and end up there. Now we're beginning here and ending up there. X equals 3, x equals 5, x minus 3, x minus 5. X squared minus 5x minus 3x plus 15 gives x squared minus 8x plus 15. And then last but not least, x equals 0 and x equals 4. So in this case, that's just x. And then you have x minus 4. So that becomes x squared minus 4x. So that one's a little bit unique in the fact that your x equals 0 is going to be just a multiplicity of x that sort of factors or GCFs in to that problem. So what I want you to do for the next 10 minutes for your homework, you're going to do problems like we just did at the end. So I put the problem sort of up top and then gave you blank boxes down here to do all of your work. And then on the back, you're going to determine if you can solve by taking the square root. And then if you get like a negative number, you would write it out as no solution. So you're doing that front and back of that worksheet. Yesterday's worksheet and this worksheet are due tomorrow morning at 7:30.